Hello there again, and welcome to Animal Science, and this is Unit 9. We're going to focus in this brief section about lactation and milk synthesis and so forth, and kind of regardless of species. We won't hit on any one specifically for very long. This is Chapter 19 in your textbook, and you can see the rather short recommended reading there, just 8 pages in your textbook. So let's get to it. You all can read the objectives quite effectively, I'm sure, here, and let's focus on 9 slides. From an introduction perspective, the mammary gland serves simply 2 functions: provide nutrition to the offspring and a source of passive immunity to those offspring. We look at cow's milk as the primary consumed milk in the United States, but it's important for us to realize that other countries consume milk from many other species, whether it's water buffalo all the way down to camels, donkeys, and sows. So they're important in other areas. And I will tell you, there's some American researchers that are studying other species and looking at the milk production from them to see if there's anything that we can breed into American dairy cows that might be successful. The mammary gland structure, each of the mammary glands is a separate structure that terminates at the end of the teat. And I say that because it's important to realize, like, the dairy cow has 4 mammary glands. It's not like that's a shared structure, a shared area where the milk is flowing back and forth from one quarter to the other. So if you get mastitis in one quarter, it's contained in one quarter. If you have production of milk in one quarter, it's in that one quarter. If you have a quarter that does not function, it's dry, has agalactia, has a problem, it's in that one quarter. It's not in the entire gland. So make sure that you understand that each gland, like on the underline of a pig, same thing. Each of those 10 or 12 glands are all separate. They're separate structure. The mammary system is supported structurally, horizontally and laterally by very, very large ligaments. Think of bungee cords that attach, like, from the belly back up underneath the rectum of the cow, that holds that udder in halves. And there's a big band laterally that goes side to side that supports that udder as well. Secretory tissue is composed of really millions of grape-like structures called alveoli that are deep into the mammary tissue, and that's what actually synthesizes the milk. Very closely connected to the circulatory system, that they're as milk-producing nutrients are delivered to the mammary system, they're taking those, combining those through cells, and spitting out milk on the other side. So the alveolus really does a miraculous job of transforming those nutrients into milk-forming components. Milk collects then in a little grape-looking structure called an alveolus until letdown occurs. It's stored there and expelled into the kind of the gland cistern, kind of an open area, a little bit of an open area in the mammary gland, in which milk is then stored until it's then ejected into the teat cistern and down through the street canal and out of that mammary gland. Here's a basic diagram, and if we look at the bottom, you'll see why I describe it as a grape-like structure. And each one of those grape-likes is an alveolus with alveoli around all the outside, and little fat droplets or milk droplets beginning to form there in the middle. You see what's around those things that looks like it has fingers or things around it. Some of those are capillaries. Some of those are also myoepithelial cells that are going to squeeze as we start to eject milk out of there. You go up into the upper right diagram, and you see kind of that almost looks like trees or a vine that goes out with leaves and branches and leaves on it, which kind of shows you what this thing looks like. You see where the gland cistern is located, kind of a collection area near the bottom of the mammary gland. The teat cistern, which is into the teat, and the street canals at the bottom. And you see the upper left picture where each of those is located in each one of the 4 quadrants of the mammary system. And that median or middle suspensory ligament where it sits there in the middle, and the lateral support ligament, which is on the side. Development of the mammary system, and here's where we can get into some really interesting and sometimes detrimental things. Growth and development of the mammary gland is rapid as a female reaches puberty. It's very important through that time that we acknowledge nutritionally that lots of very important things are going on there. We need to have females that are of appropriate body condition, appropriate body weight here whenever we are reaching puberty. I'll tell you, I've seen animals that are excessively fat, and they will actually lay fat into that mammary area, which will basically, at least for quite some time, limit the amount of milk production that they can make. So you don't want excessively thin ones, but you absolutely don't want very fat animals, because that will impede that mammary gland development that happens rapidly through the puberty time frame. The hormones that we talked about earlier in the repro section, estrogen and progesterone, very large players in that mammary development time right around puberty. Milk secretion, those growth hormones, we have some corticoids and prolactin that helps with the initiation of lactation. So once parturition, and let's just for ease of conversation talk calving here, once calving occurs, all those hormones are now active, and they're really helping synthesize milk and get it ejected. And oxytocin is the milk letdown hormone and really helps those myoepithelial cells squeeze and eject that milk out of the animal. That's stimulated by the nursing activity of a calf, or simply by the milking process. And even you'll see oxytocin release in cows. Like sometimes you all that have dairy cows, you'll notice cows will start dripping milk at a certain time of the day, or as they start to see activity around the milk barn, or the milker pump comes on, or when they enter the milking parlor, you'll see them let down their milk. It's an oxytocin response. Maintaining lactation is done through hormone function and milk removal. There's two functions there. We got to have sufficient hormones to continually maintain lactation, and don't forget that ties back to cow health, that ties back to animal comfort, that ties back to animal nutrition, that ties back to animal genetics. We got to have proper hormone function going along there in order to maintain lactation. Secondly, in the second half of this picture is consistent milk removal. So animals will continue to make milk as long as milk is being removed. Very simple concept. So if we have baby calves on a beef cow nursing, as they slow down the amount of milk that they need and begin to graze more, the cow decreases her production. And as the calf is then weaned, then because there's no more milk removal, she'll figure out that there's no more milk need to be made, so her mammary gland begins to go through involution, or that dry period where no more milk is secreted. Generally, from the point of parturition or calving or foaling or farrowing, milk production tends to increase pretty steadily for about the first 4 to 6 weeks before kind of rapidly declining. And it depends on the species how fast that occurs and how long or quick the decline period is. So it's important to realize that no matter what we're talking about from a female perspective and how long or how productive the lactation time is, all animals that make milk have to go through some what we call dry period, or some mammary involution for the next lactation to be successful. It's essential that animals have that rest period where they don't have to make any milk. They replenish milk secreting cells, they make new ones, they're ready from an energy standpoint to go again before they go through parturition and start the process all over again. Another diagram here in terms of some of the major hormones. I'm not going to belabor this anymore. You've seen a lot of this hormone stuff already, so we'll just move on from this. This just, I thought, a nice diagram for some good reference. Here's some lactation curves, and so like the upper left one, you'll see Holstein cows that calve in. Let's say they're making 50 pounds a day, and they might peak at about 45 to 65 days in milk. At this example has it at 75 pounds, and then you see the really rapid decline. You see underneath that quarter horse mares that calve in or foal in, maybe making 25 pounds of milk per day, and they stay pretty linear, pretty flat all the way out there for as long as that foal is nursing. Sows, per pig per litter, what they might be milk yielding out there. And up at the top right, you can look at some beef cattle, different breeds. So interesting lactation curves and different ways that we can influence that. things that affect milk production, certainly, and obviously we've talked quite a bit about genetics. We've talked quite a bit about feeding and nutrition before, so we're not going to, again, belabor these points in here because we've kind of talked about many of these. Management of your herd and your operation affects milk production. Animal health, and we can't get through this lactation section and not hit a little bit on mastitis, which is an inflammation of the mammary gland. We can talk more about this in the dairy section, but it can decrease easily milk production by 30% plus. And even mastitis causing cases that you cannot detect visually are probably costing you between 10 and 15% milk production on the farm. So it's very, very important that we maintain a high plane of health on our animals so that we keep incidences of mastitis out. Certainly, and you can imagine the devastating impact it would have on a baby pig litter if we have a sow that gets mastitis in one or more of her teats, one or more of her quarters, and what a devastating impact that would have on the baby pigs if there's not enough high quality milk there for them to nurse. It's interesting if you take and analyze in the laboratory milk that's normal versus milk that has a high somatic cell count. It's quite a bit depleted in milk fat, quite a bit depleted in milk protein, and quite a bit depleted in many other critical things. So the quality of that product is not near as good for the offspring or for you and I to drink as is normal healthy milk. Other things that affect milk production is the milking schedule. And you want to stay on a pretty regular schedule. So if you're on a 2 times a day milking, let's say we have a dairy operation, is we milk at 6 in the morning and 6 at night, or 4:30 in the morning and 4:30 in the evening. If we're going on 3 times a day, 6, 2, and 10, or some variation of that, and pretty regular. If we get erratic and we don't often start at the same time, then our milk production will be erratic. Animal comfort will be erratic. We'll have all kinds of crazy things that happen, and you'll notice out there, even in the pasture with foals or cow-calf operations, is calves will tend to nurse or foals will tend to nurse basically on a schedule. They kind of set their own schedule. It's amazing the way nature works that way. But the milking schedule affects the amount of milk production that an animal might be able to make. And again, milk removal rates influences the amount of milk production. So like if we get back to our dairy example, when we move from 2 times a day milking to 3 times a day milking, we can kind of expect a 10 to 15% increase in milk production. If we move from 3 times a day milking to 4 times a day milking, we don't get another 10 to 15%, but there's about a 5% bump, maybe 8% that we can get. So the more times you remove milk, the more milk that female will make. Been on some robotic dairies that have a complete voluntary system, and they'll tell us that their robot cows that are milking a lot will sometimes visit the robot 7 times a day if you let them. And so you can imagine as she gets that urge, the pressure builds up in the mammary system. She knows if she goes to the milking system, not only will she relieve that pressure, she'll get a little feed in addition to that, and that just continues to exacerbate how much more milk she's capable of making. Kind of an interesting physiological response that goes on. Again, another very important thing that we have to talk about when talking about milk synthesis is colostrum. And as fetal development occurs in a sterile environment, that fetus has no inherent immunity. So at the time of birth, we start to dump a lot of immune function and immune antibodies into that colostrum that's very high in protein and very, very high in fat to help pass on to that offspring to help fight off pathogens. A sterile animal born to a dirty environment without any of that coming along with it is an animal that's not going to survive very effectively very long. So those immunoglobulins that are transmitted through passive immunity from mother to offspring, it's very, very important. So generally, farm animals require colostrum for this to happen. There's a lot of those things that are absorbed right away into the bloodstream. Don't forget gut closure, and by gut closure I mean the ability to absorb those great big proteins reduces by half within about 6 hours, and we reduce it by half again in another 6 hours. So that doubles every 6 hours the reduction and the ability to absorb those great big proteins. So if you have a baby calf born this evening and she doesn't get any colostrum until tomorrow evening, it's very likely that she's not going to pass along very much, if any, immunity at all. And so therefore it's going to be hard pressed for her immune system to get up and running and be able to fight off any pathogens that are in the environment. So that's why it's very important to get as much colostrum as you can physically get into that animal as quickly as you can. And I'm talking about in the first 3 hours would be preferred, and maximum 6. So do whatever you can as a livestock manager, or as a consultant to livestock people out there. Increase your colostrum quality and increase your colostrum intake. And if you need to freeze and store some colostrum for future animals, do so. It's a great management technique in order to make sure you have good fresh colostrum for whatever animal might hit the ground at any time of the day. So some take-home messages to this section. I referenced that this would be a short one for you, just 15 minutes in here. Remember, lactation is not only important for profitability of farms, but for survival of offspring. That's the physiological response that many of us are taking advantage of here as a product to sell. Understand that the roles and factors that influence milk production, and how you can address those as a manager or a consultant. How you can improve the opportunity for the mammary system to synthesize more milk for you. And then lastly, just like at the last slide, colostrum management is key. And I don't need to belabor that point anymore. Just make great colostrum and make sure it gets to your babies. So thanks for listening in this section. From here on out, we're going to move into a lot of species-specific things, I believe, for the rest of the course. So as we come back to the next section, we'll start to see kind of a shift in the focus of our class. Thanks for listening. I look forward to talking to you in class.